6.1, the first problem in Unit 6, continuity, right? First question, prove that if f is continuous, then so is the absolute value of f. And then show that the reciprocal is false by finding a counterexample, okay? So first, if f is continuous, then so if is the absolute value of f, right? But the absolute value of f, right, is just the composition of this function phi with f, where phi is the absolute value of x, right? So then this is the absolute value of f. But the absolute value of x, as you all know, is this function, right? Is continuous at every point in its domain, which is the reals. And f is continuous, and so they tell us. So that means that the compositions of two continuous functions is going to be continuous. That's what the absolute value of f is, right? You could try to prove this by saying that, so the only point of discontinuity that you can think of is when f changes sign, right? But then you could compute the limits when x goes to that point from the right and the left, and you would find that the values of the absolute value of f are always the same, which is actually 0, right? So that the reciprocal is false, okay? So that if the absolute value of f is continuous, then f is continuous, right? By finding a counterexample, okay? Now, a counterexample is to find a value, a function f that is not continuous, but that its absolute value is, right? The easiest function that I can think of right now is the Heaviside function, okay? That if I can plot it properly, right? This one, it's -1, -1 when x is smaller than 0, and 1 when x is greater or equal than 0. Okay, that's the Heaviside function. Well, the absolute value of this function is 1, right, for every x, and it's continuous because it's a constant function. Now, but the original function is not continuous, okay? So that this proves this statement, right? If the absolute value of f is continuous, then that means that f is continuous, but we have found an example in which this is not true, so that means that the whole statement is not true, okay? Now the second part of the problem is what can be said about a function that is continuous, but all the values it takes are in Q, okay? That means that all the values that this function has are rational, okay? So if you, let's start with the rational, not rational, the intuitive idea to answer this question, okay? Continuous functions are those that we can in our heads, right? We can plot them without taking the pen out of the sheet, right? Or the screen in this case, right? We have a continuous line that binds every mapped point, right? Now, if a function that takes only values in the rationals, right? We know that the rationals are not, you know, next to each other in the real line, right? Between one rational and the next, okay? There are infinite real numbers in the middle, irrational numbers, and also rational numbers, right? So we could try to, so if you try to prove it like this, if we have a rational value, and then the next rational value is going to be a step away. So there's a point of discontinuity here, okay? So the rational here, the reasoning gets us to understand that this function has to be constant, okay? F has to be C, where C is a rational point, rational number for all x, right? And you can get this idea. If rigorously, you can think, suppose that f has two values, right? C1 and C2 into the different intervals from -infinity to a, and from a to +infinity, right? This is a. Now you compute the limit from the left when f goes to a from the left. The limit when x goes to a from the left of f of x is going to be C1, and the limit when x goes to a from the right is going to be C2, right? And so that means that the function cannot be continuous at A, and it will not be continuous. So the only way to get out of this contradiction is to say that f is a constant function.